Hey, hello all. Sorry for the delay. Am I audible to everyone? Okay, yeah. So today I'm here to talk about leveraging Helm Diff for safer Kubernetes deployment. Just a little bit about myself. I am Payal Godhani. I work at Oracle Cloud Infrastructure. I am a tech lead for DevOps deployment service and oversee hundreds and thousands of deployments happening every single month. So this topic, I have a very selfish interest here. I really want all the deployments to be safe so that I can have a proper rest at night. Yeah, just starting out about talking about Kubernetes adoption, I don't think I need to convince this room how prevalent Kubernetes is, but just to have some matrix around, there are 96% of the organizations are using or evaluating Kubernetes in some form or the other, and there are 76% of the services that are run in production are based off Kubernetes. It has almost become a de facto standard for the runtime container orchestration systems today. Now, talking about Helm a little bit, Helm started in 2005. It graduated from CNCF in 2020, and we have seen a widespread adoption of Helm in past few years, especially for major cloud providers. We have noticed that 70% of Kubernetes developers tend to use Helm. We see about 1.5 million Helm installs happening every single month. And yeah, Helm also has a very strong ecosystem. There are almost 26,000 public Helm charts that are available. So it's very easy to use for anyone who's getting started on Kubernetes deployments. As I said earlier, a lot of companies are adopting it. Some major players, especially Amazon, Google, Oracle, and so many more. Have anyone heard about Helm or use Helm? Yeah, so it's quite popular, right? Just for people who are new to Helm, it's a very famous and robust package manager tool where you bundle up all your Kubernetes YAML file into one one package Helm chart and deploy it to the Kubernetes clusters. It's very easy to install and maintain. And yeah, you can deploy almost all Kubernetes resources through this Helm chart. It's very easy to do version controlling with Helm. If someone wants to deploy their application through Helm, you can just do a simple Helm upgrade command and your application would be upgraded. It has a very robust command line interface and has many different commands that you could use to easily manage or deploy your application or roll it back or uninstall it if needed. Yeah, as I said earlier, it has been graduated from CNCF in 2020. That's about it. And yes, it makes the life of developers very easy. It takes away a lot of complexities away from the developers, and developers can focus on how to write their application instead of focusing on how to manage their applications or deploy their applications or manage the infrastructure. Yeah, so how it all started for us at Oracle is we had a major 7 event where someone deleted 19 load balancers out there in production, which got the whole service down. It was a major blackout. It was a 7 incident. One of our multi-million-dollar customers were affected by it, and it took us close to 9+ hours to recover this service. And this is not just one event. We had many such events out there that have affected services and our customers. So as Kubernetes is becoming more prevalent, but the guardrails and the security around it is not as robust as one would like. And one of the major reasons why we are seeing more such events in 7 and large-scale events happening today is because all the major cloud providers want to roll out new regions as soon as possible. Oracle Cloud is in 100+ regions, and so are the other major cloud providers. The SREs and the developers are facing acute amount of pressure to deploy their new features or to create their new service in a new region in record time. Like for Oracle, we have a SLA that we maintain that we have to create our service and boot up our service in a new region in 6 hours. It is just 6 hours, so you can imagine the amount of pressure the developers and SREs have to face to stand their service, right? So you can imagine that with so many production regions out there, and our SREs and change executors, they do 100 plus releases in production in a day. So it would be very hard for those SREs to understand what they are deploying. And more than that, these SREs or the change executors are not the ones who are defining the Helm charts or defining their Kubernetes applications. So it becomes all the more difficult for a service provider like us to maintain and have strong guardrails around this one. Yeah, so the lessons that we learned the hard way is to have super strong guardrails around every release. How can we make the SRE's life very easy? We had a talk earlier by Jonathan Perry who depicted a very accurate picture of how SREs typically operate and the amount of stress they are in. And they are the only ones who are responsible for having their service 100% up, having 100% uptime. We need better visibility into what we are deploying, what is it going to change on the infrastructure side, what impact is it going to cause before we start executing that. So the CI/CD pipelines need to be really robust. If there are any critical changes that are going to happen, they need to be reflected very early on, during the planning time, rather than during the execution and things failing, and then we have to sit and recover all those services. So now coming back to what is Helm Diff and why is it needed? So Helm Diff is something that fits very seamlessly with Helm. It tells you, it gives a visual diff of what it's going to change once the release is deployed. Think about it like it's a Git diff, but for Kubernetes resources. Yeah, it covers all the resources out, all the Kubernetes resources out there. Since it's a very easy visual implementation, it's very easy for everyone to see what it is going to change underneath and how is it going to change it, what are the resources that are getting deleted or modified or getting upgraded. And it has, the commands that it has is very analogous to all the Helm commands that are out there. One of the most popular one is, as you can imagine, it would be the Helm Diff upgrade, to understand what this release or what the new chart is going to do and how it is going to upgrade on the Kubernetes cluster. This is just an example of how it looks like when you run on a command line. In the first example, on the left-hand side, we see that a persistent volume claim is getting deleted, and it has a nice color coding to it so that it's very similar to a Git diff, so that it's easier for all the SREs to kind of have a visual on how things are changing around. On the right-hand side, we can see that there is a service whose port is getting updated. Again, super easy for them to see and very helpful during when they are executing so many releases. These are some of the major Helm Diff commands. The first one is Helm Diff upgrade. That is the one that is getting used the most, because most of the times you are upgrading an application out there on a cluster, right? Then there's a Helm Diff install, which shows a diff before you install a new release on the cluster. And then there is Helm Diff rollback, and hopefully no one gets to use this, because if something goes wrong in your application, then we typically go and try to understand, okay, if I trigger this Helm Diff rollback, what is it going to cause before we actually roll back on the cluster. Then Helm Diff uninstall if you want to uninstall any of the Kubernetes resources on the cluster. And with every Helm release, it creates a revision underneath. So for example, if I want to see what was the diff between, let's say, version 15 and version 17 that was deployed on my cluster, then I would do a Helm Diff revision between both of this to understand and get the nitty-gritties and those line-by-line diffs of what has actually changed. Now there are multiple Helm Diff command options that one should leverage. The first one is the three-way merge, and that is the most important one. The reason why I say is, and we are going to go on this just after the slide, but it tells you the exact live status of what your Kubernetes resources state is on the cluster, what was the last release, and what is it going to change with the new template that you are going to render. The other one that fits very seamlessly is with the detailed exit code, which tells you if you are going to execute this particular release, if there is going to be any change or there is not going to be any change. We can have a plugin that fits seamlessly with CI/CD pipelines to warn the change executors out there. Then there's an option for suppress diff. We have often seen that the lot of Kubernetes resources mutate and change, like the versions are getting updated, right? So in order, if you want to suppress diff for any particular resource and reduce the noise as part of those Helm diffs, because the Helm diffs can get pretty lengthy if you have a super humongous Helm chart and you don't want to see probably a config map getting changed, then you might want to suppress that. Helm diff by default doesn't show you the custom resources as part of the diff. So you can include this option to, if you're using CRDs, then you might want to use the include CRDs option to get an accurate diff on that. Yeah, so just to go in detail on how it is going to work behind the scenes, when it operates in multiple phases. The first part is the initialization, where it will pick up the exact chart. It loads the chart, pulls the chart probably from the container registry, parses values and implements it, and generates a Helm template. And then in the next phase, what it does is it goes and talks to the cluster, the live cluster. It collects all the status of like all the Kubernetes resources that has been defined. By using get API, get Kubernetes API, it will ask, okay, what is the state of my config map, or what is the state of my ingress, and it pulls the Helm release history. So Helm has a very unique way of storing all its release information. It stores in the form of secrets and Kubernetes secrets. So it will pull all of those Kubernetes secrets of the past release for it to do the right comparison. Now, going on to the next step, that is how it renders it. Once it has all the Helm template to render the chart with new values, it checks what is the post-upgrade manifest, applies all the changes to the template, and on the next phase, it will compare line by line diff to what is the new release that is getting deployed, and what is the current status of my cluster right now and the resources. For additions, it will just simple as we saw. The additions would be marked in green, red, and then yellow for the changes. It displays diff in a very human-readable format, which has been missing in today's Helm releases, and which is also needed at this time. And it will show you a list of all the affected resources out there. Yeah. So one question that might come up is, okay, why do we have to use Helm diff? Why just not use Helm upgrade dry run when it is already out there, out of the box command, right? So Helm upgrade dry run has limitations on it, on the way that it doesn't understand or pulls the status of every Kubernetes resource on the cluster, right? So it might not paint the exact picture. It will just give you the template that you have provided, render it, apply the values YAML to the template, and give you what you are going to deploy. But it won't tell you what is it going to change underneath, like the way Helm diff does. Helm diff goes and queries each and every Kubernetes resource out there to understand what is its resource, what is the status of the resource before generating that diff. Yes. But Helm dry run would be useful when you just want to do some local compare and work for any templating or debugging. Yeah. Could anyone tell me which one would be a Helm diff generated output and a Helm dry run one? The left one? Yeah, the left one is generated by Helm Diff. As you can see, it clearly tells you that the load balancers are getting deleted and a new app server and cluster IP is getting created. But on the right-hand side, if you were to just run Helm upgrade dry run, you are seeing that the deployment service is getting created, but you don't get to see that the load balancer is getting deleted. That is a crucial amount of information that is getting missed over here, right? Yeah. So this is what the current deployment flow in today's production system looks like. You create a Helm chart, you create all the values.yamls that fits into it, package it nicely, and upload the Helm chart into the container registry. Once you initiate the Helm deployment, the Helm charts are pulled from the container registry. They are validated by using the Helm lint command, and then SREs or change executors would just go and execute the deployment, the Helm upgrade deployment, but the service does land up in indeterministic state. What the ideal flow should look like is to introduce Helm Diff right before you do a Helm deployment, so that you get you at least get a visual diff on what is going to change, and if possible, introduce very strong guardrails after that check, and if needed, introduce a second level of approval if there are critical infrastructure resources that are getting affected before you go and execute that deployment. Yeah, these are my very strong recommendations on if you are using Helm Diff, use three-way merge, because if you don't use three-way merge, then it wouldn't pull the live cluster state and it won't paint the full picture that you want. So use three-way merge along with Helm Diff to have a very clean, reliable diffs. Detail exit codes that tell you if there is anything that is getting changed, and do control it with the CI/CD workflow. Run Helm Diff upgrade before every upgrade command that you run. As I said earlier, integrate your Helm Diff very closely with CI/CD pipelines, and introduce another level of approval if there are some major events that would take place or major infrastructure changes that are going to happen. If you want to use just do some local chart comparisons, then Helm Diff template would work. It wouldn't go and talk to your cluster. One of the things that Helm Diff needs is accessibility to the cluster, because yes, it goes and it does talk to the cluster to pull. It would need that to query the live state, right? Yeah, just closing this presentation with few of the limitations that we have seen with Helm Diff. It doesn't have as much support as we would like for custom resources. It is not able to handle CRDs fully yet. It's almost like just like a blob comparison, and it doesn't paint the whole picture that we would want with CRD. So there is some improvement that would happen that I would like to see on the Helm Diff side. There are performance issues when it comes to super huge deployments. If the Helm chart is super humongous and super huge, then to populate the Helm Diff, I have seen it taking more than 10 to 12 minutes also. So it does introduce performance slowdowns, but it does outweigh the benefits that we have in a very long run. One of the other major limitations of Helm Diff is it doesn't understand all the downstream and all the dependencies underneath. For example, if we are deleting persistent volume, then what's going to happen to the persistent volume claim that was bound to it? How is it going to affect? What is the status of it? If we are upgrading the Docker image of it, what are the changes of it? So it doesn't mimic the entire picture, but yes, it does help you enough to avoid such mishaps from happening. Yeah. That's all from me. If you have any questions, I will be around the room. Thank you.